Okay, now how does diffusion happen? Like I mentioned earlier with the whole self-diffusion, that honestly there needs to be a gap, and that's the main way we're going to have it. Vacancy diffusion. For a lot of our cases, for self-diffusion or for the solid solutions, it's going to be vacancy diffusion which will be driving it. It's where simply an atom and a vacancy will exchange positions. Now obviously the vacancy is just nothing, so it's just the atom is moving, and when the atom moves, it creates a vacancy. Now, as you might be able to guess, the more vacancy we have, the more movement the atoms can have. And also, it's going to depend on how much energy is required for that atom to move. If these bonds are really, really strong, it's going to be hard for that atom to move. If they're very, very weak, it's going to have an easier time of moving. But over time, we're going to have more and more diffusion until finally they've mixed together. Now, a second type of diffusion we can have is interstitial diffusion. It's where we have a small, and I say very small atom, and it's able to move from one interstitial position to an adjacent one. That's where it's sticking in between the atoms. It's moving into those little gaps because, in our, let's just say our simple cubic, though that's a very rare one, section, we have that big gap in the center here. That big gap in the center. And so it's able to easily move through those gaps and stay in all those little holes. Now, as you might guess, since one, it's not having to move or anything, or it's not waiting for any vacancies, it has a lot more mobility. There's no vacancies here. It's just like, okay, well, everything is vacant. I can move wherever I want because I'm small. Two, this little interstitial atom is not bound, strongly at least, to the atoms around it. And because of that, this is going to be much, much more rapid than vacancy diffusion. Vacancy diffusion, it takes time, but if enough time elapses, these vacancies move and the atoms begin to mix together. Interstitial diffusion doesn't have to wait for vacancies, and so it's all going to be based on the size difference between these two atoms, as well as the temperature, because these atoms move around, and the more they move, the easier for that interstitial atom to move between those little gaps. Now this is one of the reasons that I had you in chapter 4 solve for the max size we could have for a little atom to sit between different sites of like iron. It's because carbon does this. This is how we get carbonization of iron. It's just carbon moving from interstitial site to interstitial site because iron is much, much larger than carbon because it has many, many more electrons and protons. So, in short, vacancies are important for diffusion. And also, the gap spacing and crystal structure is important for interstitial diffusion. Interstitial diffusion doesn't have to wait for vacancies because everything's more or less vacant for it. And so it's much faster than vacancy diffusion. So, I hope this helps you, and I'll see you all next time. Bye-bye.